Good day, ladies and gentlemen, and welcome once more to Waffle TV. If this may be your first time joining us, this is Work and Philanthropy Foundation TV, where we demystify, exemplify, and simplify elementary mathematics to lay that foundation for your understanding. At Work and Philanthropy Foundation, we do not only teach, but we also carry out projects like assisting the underprivileged learners in local communities. Join us in our initiative for this 2023-2024 academic year, where we shall be supporting some underprivileged learners in some local communities. To know more about this, you can visit our website at www.wapfou.com. WAPFOU is WAPFOU.com. We look forward to hearing from you as you visit our website and identify in which aspect you can be of help. At the end of this video, we are going to provide a link as well where you can equally join us in this year's project. Last time we treated cubes and we looked at the various aspects of a cube. That is the volume, the side, and the area. This time around, we are going to be doing something else, and that is cuboid. In today's lesson, we have particularly 4 aspects we'll be looking at, and the first one is the volume, the second one is the length, the third one is the width, and the last aspect will be the height of a cuboid. Before we go into all this, we have to take note that by the end of the lesson, we should be able to calculate either the volume, the length, the width, or the height of a rectangular solid. Now, what is a cuboid or a rectangular solid? Let's look at some 3 key facts about a rectangular solid, and we'll go straight into solving some examples for your understanding. The first aspect of a cuboid is you should know that another name for a cuboid is a rectangular solid. Let's look at another aspect of it. It has 6 faces, and with these 6 faces, the opposite sides are identical. Let's look at the last fact about a rectangular solid. It has a height, a width, and length. With this in mind, let us start with the very first aspect of a rectangular solid, and that is the volume. How do we calculate the volume of a cuboid? As you have it as simple as it is, simply multiply the length by the width and by the height. This will give you the volume of a rectangular solid. Now let's look at a practical example so that we can apply this rule and see how to solve for the volume of a rectangular solid. The question reads, find the volume of a cuboid measuring 9 meters by 7 meters by 5 meters. In our previous lessons, when we were treating plane shapes, we saw the measurements given as 5 by 4, 3 by 2, and so on. And the first always stands for the length, the second for the width. In this case, we have the third aspect or the third measurement, which stands for the height. Length L will be 9 meters. Width W will be 7 meters. And height H will be 5 meters. Therefore, volume V will be equal to length times width times height. And if we substitute this, it will be 9 times 7 times 5. And this will give us a total of 315 meters cubed, which can also be written as 315 cubic meters. That is that as far as volume is concerned. Now let's move to the second aspect, which will be how to find the length of a rectangular solid. With the length of a cuboid, the rule states that to find the length, you divide the volume by the width multiplied by the height. That is volume divided by width times height. Let's look at this practical example so we can apply the rule and see how exactly this is done. This question says, what is the length of an ice block with volume 72 centimeters cube, 4 centimeters wide, and 3 centimeters high. Let's identify the various aspects. What is the volume? Is 72 centimeters cube. We have the width 4 centimeters, and the last aspect is the height, equal to 3 centimeters. Therefore, length L will be equal to volume V divided by W times H. W for width and H for height. We substitute. This will be equal to 72 divided by 4 times 3. 3 can divide itself one time, and 3 can go into 72 into 7, first of all, 2 times, remainder 1, and into 12, 4 times. 4 can go into itself one time, and 4 can go into 24, 6 times. Therefore, length will be equal to 6 centimeters. Now let's move to the next aspect, that is how to find the width of a cuboid. In this aspect of how to calculate the width of a cuboid, the rule states that the width is volume divided by length times, and this is our example. How wide is a building block whose volume is 144 cubic decimeters? Its length is 9 decimeters and 6 decimeters high. So how do we find this? First, you identify what is given. We start with volume. And our volume here is equal to 144 decimeters cube. We have the length 9 decimeters, and we have the height 6 decimeters. Therefore, width will be equal to volume divided by length times height. And we can substitute this with these figures: 144, 9, and 6. So this will be 144 divided by 9 times 6. 6 can divide itself one time. 6 can go into 14 2 times, remember 2. And 6 can go into 24 4 times. 3 can divide 9 3 times. And 3 can divide 24 8 times. Here we'll have 8 over 3. And this is the same as 2 and 2/3 decimeters. You can have your answer as a fraction, as well as you can have your answer as a decimal. All will be correct. Now let's look at the last aspect of how to find the height of a cuboid. Now our last aspect is height of a cuboid, and the rule states height is equal to volume divided by length times width. Now the example here, we have a cuboid, and the length here is 6, while the width is 5 centimeters. It says, calculate the height of this rectangular solid if the volume is 120 centimeters cube. Volume has been given as 120 centimeters cube. Length given as 6 centimeters. And the width has been given as well 5 centimeters. Therefore, height h will be equal to volume divided by length times width. And if we substitute this, it's going to be volume is 120 divided by length is 6 and the width is 5. 6 can divide itself one time, and 6 can divide 12 2 times into 0, 0. 5 can divide itself one time, and 5 into 20 is 4 times. Therefore, height is equal to 4 centimeters. With this, we've come to the end of today's lesson. Don't forget to join us in our initiative this year by visiting the link in the description to see more about this project. Next time, we are going to be looking more on 4 walls, rectangular solids which are open, and other aspects of 3D shapes. Do not miss this, as it is going to be quite interesting. See you in our next lesson. Thank you.